Hello there. Okay, so this is chapter 3 and we're talking here about the questions and answers for elements, compounds, and mixtures. I hope that you have tried the questions and found them relatively easy. If you have any problems, let's go through the answers to the questions. Okay, the first question that you have in there is a mixture is separated using the apparatus as shown. What is the mixture? Now, obviously, what he's doing is filtration. And remember that we said filtration is used to do what? It is used to separate two things. One of them is insoluble and the other is soluble. So you want a mixture in which one of them would remain on the filter paper and the other one would go down as filtrate. So let's take each one separately. So question A says aqueous copper chloride and copper. Now the word aqueous means dissolved in water. So you have a solution of copper chloride and copper, which is a metal, and metals do not dissolve, so metals are insoluble. So if I pass this mixture through the funnel, the copper is a metal, it will remain on the filter paper, and the aqueous copper chloride, which is a solution, will go down into the beaker. So actually this is my answer. Let's take a look at the others. B says aqueous copper chloride and sodium chloride. So this is a mixture of solutions. So these are two solutions mixed together. Of course, if two solutions are mixed together and I pass them, they will both go through the filter paper and they will both go into the beaker, so they were not separated. Now, if we say ethane and methane, if you haven't done organic yet, you should know that, or you will know when we do organic, that ethane and methane are both gases, and we don't use filtration to separate gases. Ethanol and water are both liquids and they mix together, so you cannot separate them using filtration. So your answer is actually A. Okay, we said before that once you decide that an answer is correct, please go through the others very quickly to make sure that they really are wrong answers, because you might have made a mistake. Okay. The next question says some chemical compounds are purified by recrystallization. What can be used to test the purity of the crystals? We said if I want crystals, which is a solid, if I want to know if a solid is pure, I check its what? I check its melting point. So that is A. Okay, what could be the melting point and boiling point of water containing a dissolved impurity? Remember we said if something is not pure, what happens to the melting point and what happens to the boiling point? Always remember, if something is not pure, the melting point is lower than it should be and the boiling point is higher than it should be. So what is the melting point of water? The melting point of water is 0. So if I dissolve something in the water, the melting point will be slightly less than 0. So my answer is either C or D. Now, what is the boiling point of water? The boiling point of water is 100. If I dissolve something in it and becomes impure, then the boiling point will be slightly higher. So my answer should be D. Do we understand that? Okay, the next question says which method can be used to obtain crystals from aqueous copper sulfate? If I have a solution of copper sulfate and I want the crystals, then of course I need to do crystallization, right? But there is no crystallization in my choices, so which one is applicable to what we're saying? Crystallization means I have to heat it to evaporate some of the water, so my answer is evaporation. Okay, the diagram shows a chromatogram obtained from 3 sweets X, Y, and Z. How many different red dyes are present? Remember we said if spots are on the same height, they are the same. So that red spot at the bottom in sweet X and in sweet Z, both of them are the same. So this is one type of red dye. Now the red dyes that are on top in sweet Y and sweet Z, they are both the same height, so this is another type of red dye. So actually you have only 2. different red dyes. Okay. Which method is most suitable to obtain zinc carbonate from a suspension of zinc carbonate? Now, if you don't know that zinc carbonate does not dissolve, you should know that the word suspension means something that is floating in the water, something that does not dissolve in the water. So when I have something that is insoluble and put it in water, it forms a suspension. So a suspension is actually maybe the opposite of aqueous. Aqueous means it dissolved in the water. Suspension means it did not dissolve. So basically I have water with something floating in it. How can I separate them? By filtration. Okay. Alcohol and water are completely miscible. This means when mixed together, they form only one liquid layer. Miscible means they dissolve in each other, so they basically make just one layer. Which method, if they're not miscible, if we say that two liquids are not miscible, and you add them together, there will be two layers. You will find that one of it is floating on top of the other. Okay. So this is a mixture of two liquids. Which method is used to separate a mixture of two liquids? If we said if we have two liquids, we use fractional distillation. Okay, the diagram shows paper chromatograms of 4 substances. Which 2 substances are pure? For a substance to be pure, we said it contains only one substance, not more than one. So to find out which one is pure, you're looking for something that gave you only one spot. So which one gave you one spot? X gave one spot and Z gave one spot. So my answer is D. Were you able to get all of this? I hope you were. Okay. Lead iodide is insoluble in water. Lead iodide is made by adding aqueous lead nitrate to aqueous potassium iodide. So basically what he's doing is he's adding a solution of lead nitrate to a solution of potassium iodide, and what he's getting is something insoluble. That means he gets a precipitate. A precipitate is a solid that comes out of the solution or forms during the reaction. So which pieces of apparatus are needed to obtain the solid product from the solution of lead nitrate? So what are we doing? We're going to add the lead nitrate solution to the potassium iodide solution. So which apparatus should I use for that? When we add two solutions together and we're trying to mix them, of course we use apparatus 1, which is a beaker. Then it's going to form, yes, and then he said he wanted 20 centimeter cube of aqueous lead nitrate. So how do I know if I have 20 centimeter cube of aqueous lead nitrate? That means I need the measuring cylinder, which is number 5. And then it's going to form a precipitate that I will need to separate from the mixture. And if I have something insoluble and I need to separate it from the mixture, then I will need the filter paper and funnel, which is number 4. So basically I need what? I need 1, 4, and 5, and that means my answer is C. Okay. In which row, sorry, the answer is already there. Okay. In which row are the substances correctly classified? Which one is an element and which is a compound and which is a mixture? Okay, element. Do you know what is brass? Okay. If you did not do it in any previous course, then brass is what we call an alloy, and an alloy is a mixture of two metals together. So brass is actually copper and zinc mixed together. Okay. Which one of these is an element? So brass is not an element because it's actually a mixture of metals. And water, of course, is not an element because water is made up of hydrogen and oxygen that are chemically combined together. So it's actually a compound. So water is a compound, brass is a mixture. The only one there that is element is sulfur. So my answer is B or C, right? Now, which of the others is a compound? Water is a compound. So my answer actually should be C. Okay. Mixture 1 contains sand and water. Mixture 2 contains salt and water. You know the difference between them. The sand and water means that I have the sand floating in the water because the sand doesn't dissolve in water. The other one contains salt and water. Salt is something that dissolves, so I have a solution of the salt. Now, which method of separation could be used to obtain each of the required products from each mixture? So in mixture 1, I have sand and water. I know that sand does not dissolve, so I can get the sand by filtration. So my answer is C or D. Okay. Now, how do I get the water? I get the water also by filtration, because when I do filtration of this mixture, the sand will remain in the filter paper and the water will just go down. So both of them will be by filtration, so that is D. Now let's check mixture 2. Mixture 2 says I have salt and water. Now salt and water is an aqueous solution. If I want the salt, I should do crystallization. If I want the water from the solution, can you see the difference? In mixture 1, it was water from a mixture of something that doesn't dissolve in the water anyway, so filtration is fine. But in mixture 2, I want the water from a solution, so I use distillation, so my answer is D. Remember that your answer is the one in which everything on that answer is correct. Okay, student wishes to extract a colored solution from some berries to make an indicator solution. So berries are fruits, you should know, something like strawberry and so on. So this is a fruit, this is a solid, and I want to extract a solution from it. Now, how do I do that? When you get berries or you get a solid and you want to get a solution out of it, so usually the first thing you do is crush the berries and then do what? And then I'm going to add something in which the colors will dissolve. So I need to add a solvent. And then after stirring and so on, and the dye dissolves in the solvent, then I will need to do what? I will need to filter the mixture in order to separate the solid berries from the rest of the solution. So my answer is B. 1, 3, and then 4. Okay? A student is investigating a colored mixture using chromatography. Where should the student place the colored mixture? Of course, this is chromatography, and we said if I have something that I'm trying to separate by chromatography, it should be on the pencil line, right? Okay. The diagram shows how muddy water can be purified. Which process for purifying the muddy water is shown? Muddy water, of course, he's saying you're going to pass it through layers of something that will remove the mud. Of course, the mud is something that doesn't dissolve in the water. So basically what he's doing is filtration. Okay, information about the solubility of 4 solids is given. A student attempted to separate mixtures of these solids using the following method. So what he did was add the mixture to the beaker of water and stir, filter the mixture and crystallize. So basically he's trying to separate what? He's trying to separate 2 solids in which one of them will dissolve and the other will not. So I need a mixture of 2 things in which one dissolves and the other is insoluble. So which of the following mixtures could not be separated by this method? Could not be separated by this method means there will be both dissolving or both insoluble. So P and R will be separated because one of them dissolves and does not, and the other does not. Q and P, where is Q and P? P dissolves and Q does not, so that will be separated. Mixture of Q and R will not be separated because both of them are insoluble, so my answer is C. And of course R and S will be separated because one of them dissolves and the other does not. Okay, a sample contains a mixture of powdered limestone. Again, powdered limestone is something that does not dissolve, calcium carbonate. Remember that most carbonates do not dissolve except the carbonates of group 1. Sodium carbonate, potassium carbonate, ammonium carbonate will dissolve, but any other carbonate does not dissolve in water. So basically I have calcium carbonate, which does not dissolve, sugar dissolves, wax does not dissolve in water. What is the correct way to obtain a pure sample of sugar? So you have sugar that dissolves, but the others do not. So what should we do? It dissolves in what? It dissolves in water. So I need to dissolve the mixture in water and then do what? I need the sugar, so I need to filter. When I filter, the insoluble ones remain on top and the sugar solution will go down as filtrate. Now, how do I get the sample of sugar? By evaporating the filtrate or crystallization of the filtrate. So my answer is C. Which method can be used to separate a mixture of salt and water to obtain both salt and water? Now, both salt and water means I want the pure water alone and the salt alone. So, will I be able to do crystallization? Will I be able to do that by crystallization? If I do crystallization, I'm evaporating all the water, so I don't collect the water. But if I do distillation, distillation means I'm going to collect the pure water alone and I will be left with the salt in the flask. Evaporation will not collect the water. Filtration will not be possible. I can't do filtration. Why? Because salt and water are soluble. Salt is soluble in water, so they will both go down the filter paper. So filtration doesn't work, so my answer is B. Okay, which statement about the boxes P, Q, and R is correct? Let's take them one by one and see which one is correct. Box P contains 2 compounds. Is that correct? A compound should be made up of different atoms. Now, each of these has the same atom. So one of them has both white, the other one has both black, but each of them are elements, not compounds, because an element is made up of identical atoms. So if I have the same atoms attached to each other, that's an element. If I have different atoms attached to each other like Q, Q has different elements attached to each other, so Q is a compound. What about R? R has some elements and some compounds, so this is a mixture. Okay, so let's see which one is correct. Box P contains 2 compounds, that's wrong. Box P contains 2 elements, okay, and box Q contains a mixture. No, Q is not a mixture. Q, each of them is the same. Each of the molecules are the same, and each molecule is made of 2 different atoms. So Q is a compound, not a mixture. Okay, box P contains 2 elements, and box Q contains 1 compound. That is my correct answer. Now, what about D? Box Q contains 2 compounds? No, it's just 1. Okay, so my answer is C. The chromatogram of substance S is shown. Some distances are labeled. How is the RF value of S calculated? We said if substance S, can you see the spot that says substance S? How do I calculate RF value? We said RF value is what? The distance traveled by the spot divided by the distance traveled by the solvent. Now, which one is the distance? All of this is relative to what? All of this is relative to the baseline, right? So I want the distance from the baseline to the spot, which is Y, divided by the baseline, the distance from the baseline to the solvent front. So my answer should be Y over X, which is C. Okay, now substances can be classified as elements, mixtures, and compounds. Again, this is definition. You try to write the definition in the correct spelling, correct English grammar, and in the correct meaning. Okay, it's always a good idea to memorize the definition that we have in the notes. If you try to put it in your own words, sometimes it comes out with the wrong meaning. So try to stick to the definition. So what was the definition of element? Element was a substance made up of 1 type of atoms. Please do not say 1 atom. It's not 1 atom, it's 1 type of atom. That means all the atoms are the same type, or all the atoms are identical. Okay? What about compound? Compound says a substance made up of 2 or more elements, and you have to continue, chemically combined together in a fixed ratio. Okay, what about mixture? Mixture is two or more substances added together. Don't say combined. Combined applies to compound, not to mixture. So two or more substances added together and may be separated by simple physical means, or they may be separated easily, or they may be separated by simple processes, for example. Okay, classify each of the following as either an element, compound, or mixture. Remember, we just said that brass is what? Brass is a mixture of two metals, copper and zinc. Carbon dioxide is what? Carbon dioxide is a compound, and copper is an element. The next question says, fill in the blanks in the following sentences. Liquids that dissolve substances are called. So when you dissolve something in a liquid, the liquid is called what? Solvent. And then the clear liquid formed after you dissolve something in a liquid, what comes out is called a solution. Okay? Okay. Explain what is meant by the term fractional distillation. How do you answer that? You have to explain what is fractional distillation, what does it separate. So it separates a mixture of liquids. Now, how do we separate it? By heating to evaporate, then cooling to condense at different boiling points. So you're trying to separate a mixture of liquids that boil at different boiling points. Okay, the following techniques are used to separate mixtures from this list. Choose the most suitable technique to separate the following. So what are we doing? Methane from a mixture of gases. Remember, we did this in the chapter on diffusion, on the first chapter. How do we separate a mixture of gases, methane and ethane? We allow it to diffuse through a porous tube. Do you remember that? So that is by diffusion. Water from aqueous magnesium sulfate. Again, aqueous magnesium sulfate is a solution, and I want which one? I want the water. So if I want water from a solution, what am I doing? Simple distillation. Glycine from a mixture of amino acids. Remember we said, how do we separate a mixture of amino acids? I should be doing chromatography. Iron fillings from a mixture of iron fillings and water. Iron fillings means tiny little pieces of iron. Of course, iron does not dissolve in water. So if you have iron in water and you're trying to separate them, then what do we use? Filtration. Zinc sulfate crystals from aqueous zinc sulfate. So here I have a solution of zinc sulfate, but I don't want the water. I want what? I want the crystals. I want the solid. So I'm doing crystallization, which involves evaporation of the water to get the salt as crystals. Okay, hexane from a mixture of liquids. How do we separate a mixture of liquids? Mixture of liquids by fractional distillation. Okay, this is one of the questions that you get at the end of the paper, or at the end of paper 6. So we have copper oxide and carbon are both black solids. Copper oxide reacts with dilute sulfuric acid to form an aqueous solution. So that means that the copper oxide dissolves in the sulfuric acid. If it reacts and forms a solution, that means it will dissolve in the sulfuric acid. Carbon does not react with sulfuric acid, so carbon does not dissolve in sulfuric acid. That means if I have a mixture of copper oxide and carbon and I need to separate them, what should we do? I have in my beaker copper oxide and carbon. That's a mixture of black solids. I want to separate them, and he's saying copper oxide dissolves in acid, carbon does not. So basically what should I do? I should add, first of all, I need to investigate the percentage of copper oxide. If he says I want to just separate them, then I don't need to wait at the beginning. But if I want to calculate the amount or the percentage of copper oxide present in the mixture, then I need to weigh the mixture first. So we say weigh whatever, 5 grams or 10 grams of the mixture using a balance, and then put the mixture into what? Into a beaker. I add excess sulfuric acid, stir with a glass rod. So in this case, we said which one would dissolve? the copper oxide dissolves. Now I'm left with carbon floating in the beaker, so I filter through filter paper and funnel. Now the carbon will collect on the filter paper, so I'm going to take the carbon and weigh it. I cannot take the copper sulfate that has been formed and say that is the amount of copper oxide. Do you understand that? Because the copper oxide that I started with has reacted with the sulfuric acid to form a different compound in the solution, copper sulfate. So what I can do is I weigh the mixture at the beginning, and then I separate the carbon, wash the residue with a few drops of distilled water, dry the residue between filter paper, and weigh. Now that's the weight of the carbon. Okay, so I'm starting with 10 grams. I end up with a certain mass of carbon. If I subtract the mass of carbon from the original mass, then I can calculate the percentage of copper oxide. Okay, so I know I'm starting with 10 grams of the mixture, and I end up with a certain mass of carbon. Then the difference between them is the mass of the copper oxide, right? Okay, substance M is a mixture of 4 dyes. 3 of the dyes have different solubilities in something called propanone. I don't care if you don't know what exactly propanone is, that doesn't matter. Obviously, it's just a solvent. The 4th dye is insoluble in propanone. Now, name the process that could be used to separate these dyes. So we said to separate dyes, I use chromatography. We call it chromatography, or you can say paper chromatography. Sketch on the right-hand diagram the results you would expect if M was analyzed as shown. So what does he say about M? He says it has 3 dyes that have different solubilities, and it has 1 that is insoluble. So the one that is insoluble will remain on the baseline, and the other 3 will have different solubilities, and they all have to be on the same line going up. Okay, so that's what your diagram should look like. Okay, why is the baseline not drawn in ink? Remember that when we draw the baseline chromatography, we don't draw it in ink. Why? Because ink would dissolve in the solvent and interfere with the experiment. Why must the level of propanone be below the baseline? We said the solvent cannot reach the baseline because we don't want to dissolve the sample in the solvent. So to avoid dissolving the sample in the solvent. The next question says the colors present in some fruit sweets can be separated using the apparatus below. The colors are water soluble, so he's telling me that the dyes will dissolve in water. First of all, name the process used to separate the colors. Of course, this process is called chromatography. Name the solvent used. Since he says they dissolve in water, then I will use water. If he says they don't dissolve in water, then I will say the solvent is ethanol. Okay, the results obtained for the colors in 2 different sweets are shown below. What is the name of the line at position B? Do you remember what's the name of the line? It's called baseline or origin line. You can say origin line. What conclusions can you draw about the colors present in sweets C and D? So let's take a look. Can you see where C is and D? So C, obviously, first of all, C has how many spots? It has 4 spots, while D has 3 spots. So that means that C has 3 different colors, while C has 4 different colors, while D has 3 different colors. Do they have any colors in common? Yes, they have 2 spots with the same height. They have the second spot in C is the same height as the first one in D, and the last spots in both of them are the same height, so they have 2 colors in common. So your answer will say they have C has 4 colors, D has 3 colors, and they have 2 colors in common. Okay, again, this is a diagram, and it says name this method of separation. Of course, this method of separation is chromatography. Now he says draw a line on the diagram to show the level of the solvent. Remember that we said the level of the solvent should be below the origin line, so you should draw something like this. And then he says, why should a pencil be used instead of a pen? Of course, we said pencil is something that does not dissolve in the solvent, while ink dissolves and interferes with the experiment. Okay, one difference and one similarity between the colored mixtures A and B. So let's take a look at A and B. one difference and one similarity. First of all, one difference is what? That A has how many spots? 3, while B has only 2. What is similar in both of them? That both of them have spots the same height as E, and that's it. Okay? So the difference is A has 3 colors while B has 2. And the similarity is that they both have substance E, since they have spots the same height as E. Which substances are present in mixture A? So let's go back. Where is A? A has spots the same height as which one? It has a spot the same height as E. It has another spot, the second spot up there in the middle is the same height as which one? Is the same height as C. And then the last spot on top is the same height as D. So it actually has C, D, and E. Okay? Okay. This is the next question. An ester was used as the solvent and the chromatogram was sprayed with bromothymol blue. Again, bromothymol blue, if he says I sprayed the chromatograph with something, that means that something is what? Is a locating agent. Remember that we said if I'm using spots of samples that do not have colors, then I cannot see anything on the paper. So after doing the chromatography, I have to spray the chromatogram or the filter paper with something that will give the spots color. So suggest why it was necessary to spray the chromatogram to give the spots color, to make it visible. Explain what is meant by the RF value of a sample. We said, how do we calculate RF value? It is the distance traveled by the spot divided by the distance traveled by the solvent. You can write it in words or you can write it as a formula. Okay, calculate the RF values of the 2 samples and use the data in the table to identify the plant acids. Remember that if I have samples, how do I calculate the RF value? The RF value is the distance traveled by the spot. So for example, for sample 1, it is the distance from the baseline to the middle of that spot, divided by the distance traveled by the solvent, all relative to the baseline. So from the baseline to the solvent front. When you do this for both spots, so that for sample 2 also the distance from the baseline to the middle of the spot divided by the distance from the baseline front, you will find that for sample 1, the RF value is 0.22. Now, when we look at the table, we find that 0.22 applies to tartaric acid. Now, when I do for sample 2, I find that the RF value is 0.46. Now, from the table, remember, you're not required to memorize RF values of anything. If he wants you to compare RF values, he will give you the values in a table like this. So the RF value for 4.46 applies to which one? It applies to malic acid, so my spot must be malic acid. Okay, chromatography was used to separate the colors. The chromatogram obtained is shown on the diagram labeled the solvent front. Where is the solvent front? Remember, the solvent front is the top line to which the solvent reaches. So when the solvent soaks up the water, where it stops, that is the solvent front. Now, how many colors were present? How many colors were present? Remember, any spots that remain in the end are the colors. Even if you have a spot that is remaining on the baseline, you're going to count it. So these are actually 3 colors. And we said, why is it that some of them go up and the other remains on the baseline? That means that the one that remained on the baseline is just insoluble in the solvent, while the others dissolved to different extents. Okay? Now, this is a question. E110 is sunset yellow. Outline a method you could use to show the presence of E110 in a food coloring. So you have a sample of food coloring and you want to know if it has E110 or not. So what you do is you put a spot of the sample next to a spot of the E110 on the baseline near the bottom of a chromatography paper. So put a spot of the food coloring next to a spot of E110 on a baseline near the bottom of a chromatography paper. Put the paper in a beaker containing a very small amount of what? Now, we said if we're talking about food colorings, Food colorings usually or almost always dissolve in water. So if I'm talking about, remember we said, if I'm talking about ink, or I'm talking about food colorings, or I'm talking about dyes or something, then these this dissolve in water, so I use water as a solvent. And then allow the water to move up the paper. How do I know if I have E110? You have to tell me. So you're explaining chromatography, and you have to tell me, okay, I've done it. So what should I see, or what should I, how do I determine whether it has? You should know that if the sample has a spot the same height as the E110, then it has E110. Okay? A list of techniques used to separate mixtures is given below. From this list, choose the most suitable technique to separate the following mixtures. A technique may be used once, more than once, or not at all. So, again, he says butane from a mixture of propane and butane. All of these alkanes are gases. How do we separate a mixture of gases? We said by diffusion through a porous tube. This was done in the first chapter, after diffusion. Okay. Oxygen from liquid air. Now, you should know that air is a mixture of gases. Now, if I cool it, it becomes liquid. So, it becomes a mixture of liquids. How do we separate a mixture of liquids? A mixture of liquids is separated by fractional distillation. Water from aqueous magnesium sulfate. So, I have a solution of magnesium sulfate, and I want which one? I want the water. I do a simple distillation. Potassium chloride from aqueous potassium chloride. Now I have a solution, but I don't want the water, I want the salt. If I want the salt from a solution, I do crystallization. Okay? Silver chloride from a mixture of silver chloride and water. Now you may or may not know that silver chloride is something that does not dissolve. So if you don't know, please learn that silver chloride is something that does not dissolve in water. So basically I have something that is not soluble and I have it in water. How do I separate it? By filtration. Glucose from a mixture of glucose and maltose. Glucose, maltose are sugars to separate a mixture of. Remember, if he says sugars or if he says amino acids, then we are separating them by chromatography. Okay, so that is the end of the questions. I do hope that you were able to do at least most of them.